Welcome, everyone. Good morning, and welcome to another GMI technical training. I am very happy to be here today, co-hosting this event. I'm being here with Bob. Hi, Bob. Good morning.
Hey, Barbara. Good morning. Good morning, or good after, or good evening for everybody else, or wherever you are in the world. I know we have people from all over the place that are joining us. So it's 10 a.m. here in Houston, Texas, and I know it's 5 p.m. in some parts of the world. So thank you for joining us.
Yes, we are very excited to do this topic today. I believe we did a couple of years ago, but it's always good to review the standard and clarify any open questions our attendees might have.
Yeah, and before we get going, this is just a little bit about Barbara and myself, and Barbara will kind of do a little bit about GMI for the first few minutes. If you do have some questions as we go along, we've muted you guys, but you can certainly provide a chat to be able to send some information. So we've also taken a lot of questions that have been brought up, and we've put those together at the end of our presentation, some of the key questions that people asked. So we'll have some time to be able to do that. And then again, if there's any other questions during the webinar, please feel free to go ahead and put a chat in there. This will be available on the GMI YouTube channel, available as well. And then for anybody who's actually registered, I think, Barbara, they're sent out a little certificate. Is that correct, I think?
That is correct. Our communications team will check the participation, and as long as you guys are here for 75% of the presentation, you will
There
get
you
an
go.
email with the link to the recording, a PDF of the presentation with the questions, and your certificate of attendance.
Fantastic. And
Mhm.
Barbara, I'll let you kind of take it on from here, and then you want to do introductions, talk a little bit about GMI, and then we'll get into the meat of it.
Yes, that sounds like a deal.
All right.
So again, welcome everyone. My name is Barbara Vasquez Isla. I am part of the GMI, the GM International team here in North America. I am based in Houston, and I support the sales team and our customers from North America and South America. And I'm here today with Mr. Bob Johnson. For those of you that haven't met Bob, he has more than 30 years of experience in electrical and mechanical installations in hazardous locations for standards such as IECEx, ATEX, as well as the North America CEC and NEC for Canada and United States. So he is very well prepared for today's topic on the standards and the wall chart. Mhm.
Thank you, Barbara. I hate this. I hate when you say that many years. Actually, it's 40 years now. So I'm like, holy cow.
Well, but hey, you know, experience is so important. And I didn't mention that, but yeah, you also do inspections, right? I think mainly in the Gulf Coast, so
Yeah,
offshore
no,
inspection.
yeah. So we'll do EX inspections. We're a Compex provider as well as an IEC EX recognized training provider, and we'll do training. Last week, I was just telling Barbara I was up in North Texas doing training. Uh, my colleague was doing training, and then we also do inspections. So I've been kind of traveling all over North America on the behalf of certain clients to do actually full-blown EX initial detailed inspections. So yeah, it's definitely something that we do as well.
Mhm. Perfect. So, like Bob was mentioning, I'll start with a little bit of an overview of who is GMI. For our attendees that are not familiar, GMI, GM International, designs, engineers, and manufacture interface devices specifically for functional safety and intrinsic safety applications. Some of these applications will be your emergency shutdowns, your fire and gas systems, burn management systems, high integrity protection systems, and all these typical applications with DCS and PLC automation solutions for the process industry, which will be oil and gas, petrochemical, pharmaceutical, mining, for example. We are an Italian company. But like I was mentioning, we have offices all around the world. Um, and on the next slide, uh,
Sorry.
you you will see that quality is one of our main pillars of our organization. Our production is done in Italy in a state-of-the-art facility where every single component is 100% tested before it's being shipped. So you will receive a product that has been tested 100%, and quality will obviously be part of these products. We follow all the standards, like I was mentioning, we're Italian companies, so we follow the European standards, ATEX, but we are international companies, so we follow IECEX, and we are in North America, so we follow also the North American standards. This is a glance of our product portfolio with intrinsically safe galvanic isolated barriers, safety relays, signal conditioners, power supplies, temperature multiplexers, HART multiplexers, CO3 and intrinsically safe surge protectors, and our new X1 series, which will minimize the wiring in your marshalling cabinets to provide the safety relays or intrinsically safe type of signals. Mhm. Um, Located all over the world, so we will always be there will always be someone from the GMI team in your time zone. I know that's very important for our users, for the user experience. Mhm. And some of our customers that we have had the pleasure to work with in the last 30, 40 years from the company, we have system vendors, EPCs, OEMs, and of course, end users. So
There you
now I pass the microphone to Bob Johnson so we can start the technical training.
Okay, well, thank you, Barbara, and thank you for sharing us a little bit about GMI. And I do want to share this just on a personal note. I've known the folks from GMI for many, many years, and well, the one thing we do supply EX equipment as well. And one of the things I've always really enjoyed with working with GMI is, I can talk to pretty much anybody within an organization, and they respond very quickly, and that's a nice thing. It started off as a family-owned business. It's still many of the original family members are still part of the organization, and it's nice to be able to actually pick up the phone if you have to talk to somebody and actually get an answer on something. So unlike some of these other faceless, nameless large corporations, they're very easy to deal with, and getting answers is always usually very easy. So a little bit about wall charts, and we give these out, and GMI makes them, and there's a ton of them out there, right? And these are fantastic tools, and you will get these from vendors, from certification bodies, manufacturers, and they're all fantastic. And they all are basically telling you the same thing, but they may be telling it to you in a different fashion. And unfortunately, the problem with wall charts, as soon as they get published, or they get printed, usually the standards change. And so then in some cases they're out of date. But everybody here can go ahead and get and request a GMI wall chart at the end of this webinar. So you'll be able to actually access it and get one for yourself. So there's a lot of information on these wall charts, and usually when I give them out, instead of just handing them out to somebody, I kind of try to go through it and explain a little bit of details of what actually is on here, so you can actually kind of use this as a tool. So I realize many of you are looking at this and the font is pretty small. So I'm going to go ahead and break it down into various sections of a typical wall chart. And again, different companies will put different information on there, but there's a lot of similarities, and the information is really relevant. So kind of just going through it a little bit, starting with area classification. This is always a question that people try to figure out, which standards do we use for area classification? And within the international world, we pretty much follow the 60079 10-1 and the 10-2, depending on if it's gases or vapors. But sometimes we'll also use what is called the Energy Institute of Petroleum 15, which is an area classification document. And then in the United States and some parts of the world, we'll actually follow what are called American Petroleum Institute recommended practices. specifically the 500 and the 505, or an NFPA document. So looking at this chart here, where we're talking about it, when we talk about groups and we talk about zones, anything under the ATEX where you see a group, excuse me, a group 1 is considered to be a mining application. A group 2, if you will, is considered to be a surface industry. And within your wall charts, you'll see there's somewhat of a definition as to talking about the protection concept of the equipment that's going to be suitable for those particular areas, either a very high, high, or normal fault condition tolerant type product. Excuse me, I'm getting over a little bit of a cold. I apologize for coughing. So again, we furthermore break this down M1, M2 for mining. Then we have surface equipment groups, 1, 2, or 3. And then we have a G or D for gas or dust hazards. Excuse me. That's kind of the ATEX marking requirements, where under IECEx, we have 3 different equipment groups called EPLs, and these are considered to be either 1, 2, 3. Excuse me. No, excuse me. It's either a GA, GB, or GC, depending on the zone of use. Yikes. Apologize. Barbara, I might have to have you take over here a little bit if I can't get over this. Anyway, what we're going through here, again, we have some additional information. ATEX will reference the equipment category, where the IECEx references equipment protection levels. So the key thing to note on this, where you see something that says ATEX category 1G, that basically means the exact same thing as GA under the IECEx scheme. Now, for division applications or North American applications, we in effect have 2 different methodologies that we can follow. In the US, the legacy was more or less defined within the National Electric Code as Section 500. For the zone concept, we use Article 505, which is the zone concept. So in the US legacy facilities, we would have either a Division 1 or a Division 2, and we would have a class hazard. Class 1 would be gases, Class 2 would be dust, and Class 3 would be fibers. And how this kind of breaks down, if you will, in comparison to the zone concept, really a Division 1 area in the United States, oh my goodness, would be a combination of Zone 0 and Zone 1, where a Division 2 is very much similar to a Zone 2. So let's do a quick poll question. This will allow me maybe to go grab a little water, and I'll be right back. So let's see. Can you launch the poll?
No, I think you have access to the
I
poll.
have control. Well, you know what? We'll skip that. How's that? So the answer for this for a Zone 1 is an area in which a gas vapor hazardous atmosphere is present, excuse me, frequently or continuous, or excuse me, normal operation, place where dust, no, it's not D. C, where gas vapor atmosphere is not present occasionally during, but occurs infrequently, it's not C. And B would be the correct answer. Place where a gas vapor hazardous atmosphere is present occasionally during normal operations. If it's frequently or continuously, we consider that to be a Zone 0 environment. Excuse me. So why do we subdivide these gases and vapors? We need to determine this based upon really a couple different things. The main factors. Oh, go ahead. I'm
Yes,
sorry, Barbara.
sorry, Bob. Let me interrupt you there. We have a question that I think will be a good time to talk about it. So they're asking, may you please explain the meaning of class in North America classifications? And I can go over that if you want to. So in North America, we have Class 1 and Class 2, where we talk about Class 3, when we talk about the type of explosive atmosphere we have, right? Which will be gas, dust, or fibers. When we talk about zones, That when we have like the zone 012, which is gas, 2021-22, which is dust and fibers, right? So that's how in North America we will recognize what type of explosive atmosphere we're dealing with. So,
Yes.
mhm.
Yeah, yeah. And so this slide kind of somewhat explains a little bit about that. So the class one, division one, again, that's a gas hazard. We would consider that either a zone 0, zone 1, or zone 2. If it's a dust hazard, then we consider that a zone 20, 21, or 22. The same thing in the IEC world, we don't segregate dust and fibers into two different classes like what we do in the US. We lump those all together. So those are considered to be dust and fiber hazards. So in the US, we've broken that out, and so that's a little bit different. But if in effect, anytime anybody mentions a class one area, gosh, I apologize. A class one area is a gas vapor environment. So some of the gases will then get subdivided. And it's important to do this because we need to understand when we get into protection concepts, what are the key criteria, depending on the protection concept, how we address these particular gases and vapors. And it could be based upon the pressures, it could be based upon the minimum ignition energy, it could be based upon the temperature codes, which we'll talk about here in just a second. So there are, in the US, we subdivide into 4 different gas groups. So we have A, B, C, and D. In the IEC world, we have 3 different gas groups. So we lump hydrogen and acetylene in the same gas group in the IEC world, where in the NEC world, we keep hydrogen separate. And then all the other gases and vapors that you'll find in industry generally will fall into either a 2B, 2A, or Group C or Group D gas, if you will. And we do something similar in the fibers, where we deal with those. We call those groups 3, and we'll call those a 3C, a 3B, or a 3A, and that's how we kind of subdivide these. So again, in many cases, what we're seeing, there's a lot of similarities. We just call it something different here in the United States. A little bit about ingress protections, and we did have a question that came up with regards to IP ratings and NEMA ratings. Stands for National Electrical Manufacturers Association, and they have published a document. It's been around for many, many years, called NEMA 250. And this document basically defines ratings for enclosures. And we'll have ratings that you'll see things from anywhere from a NEMA 1 to a NEMA 13. And you'll see kind of a list of all those different ones. In the international world, we talk about IEC, ingress protection codes. That's based upon the 60529 standard. And the big difference is here is that NEMA ratings also include testing for corrosion resistance, where IP codes do not. They just strictly test against either solids or liquids, where NEMA ratings actually say, hey, what about the corrosion resistant characteristics of this enclosure? So that is a difference. The important thing to note here is some people will say, hey, can I just use a NEMA rated box for an international application where they require an IP rating? And I will always tell them I wouldn't do that. They do overlap, but it is a different testing procedure. And the same thing holds true in the US. If you're doing a US installation, I would use a NEMA rated enclosure as opposed to an IP rated enclosure. Now, in many cases, a lot of these enclosures from big manufacturers will have both. So just be aware that that's a requirement for enclosures. Now, temperature codes is another area where we're slightly different than on the international side than what's done in the United States, but it's the same concept. In the international world, we have 6 temperature codes that are associated with this. There's what is called a T1 through T6. In the United States, under the legacy division concept, we introduced intermediate temperature codes. So you would actually have, in addition to maybe just a T2, we would break it down even further to maybe a T2A, T2B, so forth and so on. The whole concept with temperature codes is what we're trying to do is every gas and vapor that is a flammable gas or vapor will be assigned a temperature code. And what that temperature code means is that if we have a product that is rated, for example, a T3, that means if the gas is a T3 gas, that means that that gas will ignite at a temperature somewhere above 200 degrees C. If we have a T3 rating for a particular product, that means that the relevant surface temperature on that product will never get to that point. So we have to take into account temperature codes when we're selecting product. But before we select product, we have to identify the temperature codes associated with the ignition temperature of the flammable gas to make sure from a heat standpoint that our products will never get to the point where we could have a spontaneously ignition of the flammable gas. So generally speaking, with regards to T codes, enclosures, non-real heat producing devices generally will have T codes of somewhere in that T6 to T5 to even a T4 range. And generally those are going to be suitable for about 90 some odd percent of the applications out there. When we start getting into products like transformers, light fixtures, a lot of heat producing devices like maybe a VFD, then our T codes start going up, and maybe instead of a T4, it's maybe a T2. And this is where we really have to be and pay particular close attention to make sure that we make well that those products are not going to exceed the ignition temperature of the gases or vapors. So we'll kind of skip this one, but a T code for a product has a maximum relevant surface temperature under a normal or fault condition of 125 degrees. So the T codes, T6 is 85, T5 is 100, T4 is 135. So in this case, this product, the relevant surface temperature is 125 degrees C. That is below 135 degrees C, which is a T4 rating. So we would mark this product with a T4. So now we get into part of the wall chart where we start talking about the protection concepts and the standards and the suitability of these particular products. So there's really, when we think about the protection concepts, in particular for gas applications, there's really four major concepts, and we break it down into this. Energy limitation, like intrinsic safety, we're limiting the amount of energy. Non-sparking, where we have no arcing or sparking, but we have to make sure on creepage and clearance distances, we would call this increased safety. Containment, where we're taking an arcing and sparking device, putting it in a cast enclosure, we're containing that explosion inside of that enclosure, making sure it doesn't propagate to the outside. And then finally, separation, where we're removing the gas from any potential ignition source by the use of maybe pressurization, oil immersion, so forth and so on. For dust, we basically talk about energy limitation, again, intrinsic safety, or separation, dust ignition proof, pressurization, and others. So you'll see on the right-hand side, you'll see the IEC EN standard, and you'll see the US standard. In many cases, a lot of those US standards are being harmonized with the IEC standards, and we're now introducing them as a UL version of the 60079 set of standards. The important thing to note here is if I'm a designer and I'm selecting equipment, I don't necessarily need to know all of the details of those particular standards. Those standards are for manufacturers that are building equipment using those protection concepts. So if my role is product development or product engineering, absolutely I need to understand those standards. If my role is more like applying these particular products in a design system, I don't necessarily need to know all these details, but I do need to know some of the other ones that are published. So just as an example, we're limiting the amount of energy below the minimum ignition energy for the particular gas group. This is typically the use of intrinsic safety. And it's divided up into three range of fault tolerance. There's called EXIA, IB, and IC. And so when we looked at the wall chart where it talked about fault tolerance, in this case, the highest level of intrinsic safety is a double fault tolerant, meaning that we could have two separate individual faults of an intrinsically safe circuit and still be safe for use. If we have an IB circuit or an IB barrier, in an IB loop, if you will, that means we can only have a single fault, and that's only suitable for zone 1. And then if it's not fault tolerance, that means there is no redundancy, if you will, then typically that's only going to be suitable for zone 2. Non-sparking, a good example of this is increased safety enclosures, where basically now what we're saying here is, as long as there's no arcing or sparking taking place on the inside of this enclosure, therefore we're going to assume gas vapors get on the inside, but there's no arcing or sparking, so therefore enclosures manufactured of sheet metal or plastic or polyester are perfectly suitable for those applications. So typically what we have to do is what we do need to do, the only items that we can put on the inside of these enclosures have to be certified in and of themselves. So a prime example is terminal blocks. But we could have relays, we could have switches, we could have different components that will all have an individual EX certificate. And depending on the manufacturer, depending on the certificate of the manufacturer, these can all be used inside of these enclosures. However, the important thing to note when we're using this concept, we have to validate and make sure that we don't put anything in those enclosures that are not listed specifically within the certificate. Then some of the other protection concepts of containment, many people are familiar with flame-proof, but there's also what is called powder-filled and enclosed break. So powder-filled is where maybe we're taking a switching device, maybe a PC board, and we're encapsulating with a very, very fine quartz powder. That's considered to be EXQ. Enclosed break might be actually a small switch that's enclosed within a housing. So that's considered that's containing the explosion and not letting it propagate to the outside atmosphere. And then finally, our separation, and we could do it in different ways. Encapsulation, where maybe we're taking a printed circuit board, encapsulating in a resin. You might find solenoid valves as a prime example, what's in the industry that's being used. Hermetically sealed, some switches are actually considered to be hermetically sealed, they're gas tight. What's very common is pressurization. So we have different pressurization techniques for different zones. We can also do oil immersion, where we're taking any arcing device and immersing it in an oil bath. And then finally, we have what is called restricted breathing, where we're restricting the gas air mixture from entering on the inside of either an enclosure or a light fitting or something like that. So again, we're removing the gas flammable mixture from the source of ignition. Now, EX markings. And this is where it always gets interesting because people see all this on labels. So we'll spend a little bit of time on this. But on the wall chart, you'll see on the left-hand side there, the North American markings, and this is what you would typically find on a product. You'll see something that'll say Class 1, Division 1, it's gas groups, and typically a T rating as well. If it was designed specifically for a zone system in the US, we would actually call out Class 1, the zone. In this case, we would actually put an A in front of the EX, and then the EXIA 2C, T4 would be basically the same markings. And now actually we've included the EPLs. So in this case, we would also have at the end of that marking string for the US application, we would find what is called a GA. Now we look over on the right-hand side, you'll see in the very front, the directive marking, which is the CE mark, the certification or quality product certification body in this case. The EX, the hexagon, and the EX, Roman numeral 2, telling it's for surface industry, category 1G, which is basically an environment as if it was a zone 0, and then the protection concept. So in this case, EX, IA is the protection concept, intrinsic safety, the highest level. It's suitable for 2C gases, and if it's suitable for 2C, it's also good for 2B and 2A. There's our temperature code associated with it. So this product will never exceed 135 degrees C at its maximum ambient. And then finally the EPL. Now down below that, you'll see a certificate number for ATEX, and you'll see a certificate number under the IEC EX. And then at the end of that certificate, you may see an X or a U. If it's an X, that means there's some sort of special conditions for safe use that we have to pay attention to. If it's a U, that means it's only a component and cannot be installed in and of itself by itself. So that's an important thing to take note of if we're selecting products, to pay attention to those certificates. I always tell people that if you're in the EX world, and again, I do inspections, I'll see a lot of products that are installed that are not installed in accordance to either the X conditions, or I'll see them installed with maybe a U component. So we don't want to do that. We want to make sure that we select our equipment according to the standards, and we also take a look at this stuff before we actually procure equipment. It's a good idea. Don't buy anything unless you've had a chance to look at those certificates in a very detailed way.
And we have a few questions.
Yeah.
Bob, maybe it's a good time here. One of the questions will be, when you have an enclosure, in what classification can you open the enclosure to do inspections in a zone 2 under power? So when the enclosure is energized in a zone 2, can you open it when it's EXI, so intrinsic safety, or
Yes.
EXE, increased safety?
Yeah, so we cannot open up any enclosure while now, I say this, the standard does allow us to open up intrinsically safe equipment while energized without a gas-free permit. So now some companies will not allow that, but you can do that as per the standard. All of the other protection concepts, we're not allowed to open them up. If we're doing an inspection, that's called a detailed inspection, meaning that we're opening it up. And that means that we have to lock it out, tag it out, we have to de-energize it. And then typically, even before that, we're going to do a gas-free permit. We're going to do a lockout, tag out, and all that. So generally speaking, regardless if it's zone 0, 1, or 2, we're not allowed to open up any of these enclosures or pieces of equipment while a flammable gas is there, unless we've taken some sort of special precautions. We may have gas detectors with us. We've sniffed the air. We make sure that we're at least 25% below the lower flammable limit of whatever that gas or vapor is. We definitely want to de-energize this. And then at that point, then we can go ahead and start opening up pieces of equipment. But unless, and many companies will have various procedures on how to do this. But again, yeah, we don't open up equipment unless it's been fully de-energized, and generally only at that point when we have a lockout, tag out, to where and there may be some issues, energy storing devices like capacitors on the inside of an enclosure. We have to let those discharge before we can open it up. So those are kind of generalities.
One more question. So if you have an IP66 stainless steel junction box, is it a NEMA 4 equivalent? Or do you still
Yes.
need a NEMA 4 certificate if that's what the customer is requesting?
Yeah. So the NEMA standards, when they originally came out, were basically more of a voluntary. I mean, it was used by all these box manufacturers. Again, it came out from the Electrical Enclosure Manufacturers Association as kind of like, hey, this is a good idea. And then there are tests that have been developed, and people can actually submit their products to get them tested to those NEMA standards. And then they'll have a test report from one of the testing labs, like a UL or CSA or FM. Is it fair to say that if I have an IP66, that's the same as a NEMA 4X? Well, the issue is on the IP codes. The IP codes, again, address water and solid objects. So it would pass probably the NEMA 4 test for sure. If we actually compare the NEMA testing versus the ingress protection. But I can't necessarily just say that my IP66 piece of equipment is necessarily considered to be corrosion resistant to meet the NEMA 4X test. Now, on the other hand, if I have an IP66 enclosure It is manufactured out of a stainless steel material. I could probably say with confidence, it probably would be the equivalent of a NEMA 4X. But that being said, that's me saying that. Do you want proof? Uh, at that point, you would have to reach out to the manufacturer and get that document and do that.
Mhm.
So you will find in many cases, some of the large enclosure manufacturers now that are selling products worldwide, they will have both a NEMA rating and as well as an ingress protection rating on their enclosures. So, that's the ideal situation. Again, I wouldn't just take a IP rated enclosure, use it in a NEMA area. Um, just, I don't want to be the one to tell you to do that. And then 6 months from now, you're going to get all yelling at me. So I'm not telling you to do that. Um, and vice versa too. If you have an ingress protection requirement and you want to use a NEMA rated box, I wouldn't necessarily just go ahead and do that as well because they may or may not, the client may or may not accept that because technically they're not the same.
Perfect. And the next question is if you could explain the marking when they use brackets, which I think that's this
Yeah,
slide.
and actually, this one is, and this what we're looking at right now is an example of where we have brackets. And this is actually slightly out of date. Excuse me. But this is actually an old marking from a GMI barrier. So what you see is the first line there, you'll see the Roman numeral 2, the 3, and then a 1 in parentheses. So what that is, that's our ATEX category, meaning it's good for category 3, which is a zone 2 gas atmosphere with the G, but then we see the parentheses with a 1. That means that the output from the barrier itself is actually output is suitable for use in a zone 0 environment. Then you see an EXNA that's now been replaced with EXEC, which is a protection concept, increased safety, in which it's suitable to be installed in a zone 2 area. But then I see those brackets, IAGA, which is telling me in effect the output from this device is actually suitable to be used as protection downstream into a zone 1 area when attached to a particular piece of equipment. Then we'll see a T or a gas group, 2C, which that applies to the device of where it's being installed. The T4, again, where it's being installed, the barrier. And then finally GC, which is our IECEX marking. Now the line right below that, that's for dust applications. And in this case, this particular product cannot be installed in a dust application. It would have to be installed could not be installed in, say, a zone 22 area. It would have to be installed in a safe area or installed in an enclosure that's providing dust protection. And then the final line that you see there, the Roman numeral 1, that is for mining applications. When you look over on the right-hand side, you'll see an IECEX certificate. And then right below that, you'll see the same markings, except you don't find the ATEX category markings. You will just find the EXNA. But notice that the ATEX marking and the IECEX marking is basically the same, with the exception of the Roman numerals and the categories. So that's what that means. And I think in your question, you actually had something where it was maybe an EXDB, which could be a flameproof box. And if you had an IA in brackets, that would mean basically I've got a flameproof box where it contains intrinsically safe barriers, if you will. We would call those associated apparatus that is feeding out of the flameproof box into a hazardous area. The same thing could hold true if I have a pressurized enclosure. I might have an EXB, which is telling me that I've got a pressurized panel that's suitable for zone 1, but I want to be able to have the controller for that control something that's going into a zone 0, and I put my intrinsically safe barriers. So the marking on the marking string for that pressurized panel would include in brackets an IA. So that's telling me that that pressurized panel has some intrinsically safe barriers inside. That's what all that means. Now, here's another example, and I know we had a question, I think it was about the supplemental marking strings, but this is an example of a flame-proof box. As you can tell in this case, it does not contain any intrinsically safe barriers. So it does not have a bracket with an IA, but it does have a gas group of 2B plus H2, which is basically saying in this case, it's good for 2A gases, 2B gases, plus hydrogen. Then it'll have a temperature code and then our EPL. And then we'll see an IP66/67. One of the things that I didn't really mention about IP codes, the IP66 test is actually a more onerous or more difficult test than the test for IP67. So IP66 is a very severe hose down test, where an IP67 is temporary immersion in water. So it's actually more difficult to achieve an IP66. So one thing that I just want to point out that's really important is that with regards to ingress protection codes, we can usually make the assumption that the higher the number, the higher level of protection. That's not always the case. And especially if you're working on a project in which maybe either you're specifying IP66 or maybe you're having to supply equipment that's suitable for IP66, don't make the assumption that I can just use a piece of equipment that's IP67, thinking that 7 is better than 6, because in this scenario, it's not. So what manufacturers will actually do, and you'll see this, they will actually mark it in this case with both 66 and 67. And you'll actually see some cable glands that will be marked 66, 67, and 68. So that's kind of just something to keep in mind. Now, we talked about the flame-proof gas protection concept, DB, but then you see below there, there's what is called EXTB, Roman numeral 3C, T100 DB. The TB is a dust protection enclosure for the most onerous gases. Then instead of a T6 or a T5 or a T4, we actually put a T with the actual ambient or surface temperature. What that number is, that T100 is saying, if I put this box in a highest ambient that's its rating at plus 55, then at that point, if I have a dust layer of dust that gets on the outside of this, that enclosure will never exceed at that layer temperature of more than 100 degrees C. That's the surface temperature of this enclosure. Now, it's pretty hot. Now, the way we select these products based upon dust hazards is that we take that number and we look at the ignition temperature of the various dusts. And we have to have a 75-degree rise above this. So what that means that if I had a dust that ignites at 200 degrees C, I could use this enclosure. If I had a dust that ignites at 150 degrees C, I could not use this enclosure. So that's what that means. There was a question too. Can a certificate be given without a certificate number on the equipment? That's a good question. I would say no. I'm not I don't know of any time where I've seen that where it shouldn't be marked on the piece of equipment. Other than I have seen instances where manufacturers will have different labels, and they may have a label for one certification, but yet they actually do have another certificate that's not listed on that label. So I could see that as being a scenario. But if the label is to reflect that particular installation or certification, it should have the certificate number on that label. Under ATEX, however, you can actually, for Zone 2 applications, do what is called self-declare. And at that point, you're not getting a certificate number from a notified body. And in that case, you would actually reference a test report. So it's not a certificate number per se, but it's actually a test report. And that's the requirement that is a requirement under ATEX for Zone 2 and Zone 22. But without that exception, generally speaking, I would expect to see the certificate number on that label. So we kind of talked about this, but I'll just give you the answer again. DB is flame proof. It contains an associated apparatus. It is suitable for a 2C environment, which is a zone 1 area, and the output is suitable for zone 2. So number one, suitable for 2C, located and contains associated. Yeah, I'd say that sounds good. Number two, flame proof 2C, located in a zone 0. Nope, I can't put this box in a zone 0. A flame-proof enclosure suitable for 2C gases containing increased safety relays. Nope, it's not increased safety, it's intrinsic safety. And it's not a pressurized enclosure. So the correct answer would be, in this case, A. Now, to kind of finish up a little bit and get in some more Q&As, there's another chart that is available. And I know many of you have probably or have questions on functional safety. And there is a wall chart that GMI has put out that's very helpful. I don't run into functional safety as much as I used to, but it is very helpful. This is the one chart I don't have up hanging in my office, so it is a relevant tool. And here's the thing I want to highlight, right? Wall charts can be useful if you know how to use them. The information is right there. Take your time to quiz yourself periodically on the chart. Literally read it, right? And then actually ask yourself, what does this mean? And here's the other thing, right? As soon as it gets published, it's generally out of date. So make sure that whatever chart that you're using, make sure it comes and it is updated. And again, these do get changed quite dramatically because the standards, directives, requirements all do change. And again, we're only as strong as the weakest link, and don't let you be that weakest link, right? So with that, we'll skip this, skip the thank you, and maybe just get into some of the questions that were raised. And I know we have some additional questions. We'll go through these at first. So a little bit about, can EXI signals, blue cable color, share cable tray with non-EXI signals, black color cables? Yes, and yes, you can. There is a couple different things. And by the way, there is not this is a little bit confusing with regards to I must always use blue cable for intrinsic safety. What the standards say is that if I am to use a color code to identify intrinsic safety, it says it shall be light blue. But that doesn't say it must be light blue. It just says if we are to use a color to identify it, we use light blue. So could we use an additional or non-color identification to IS circuits? Yes, we could use tags. We could maybe use blue heat shrink. Does it have to be blue cable the entire way? Not necessarily. So there is a little bit of misconception in the world that it must be blue cable, and that's not necessarily the case. However, there are a couple things. If we have IS cables, we cannot run IS and non-IS in the same cable. We can put them in the same tray. And actually, we don't even have to worry about separation of them if one or both of those cables are shielded or have some sort of mechanical armor. So if I have an IS cable that's non-shielded, although most of the time it would be a shielded cable, and I have power cables right next to it, I don't have to worry about maintaining my separation. If they are non-armored shielded, then I have to either maintain a 50 mil separation, or I can use a grounded earth partition in some way, shape, form. So there are different ways to address IS. The key thing is we do need to identify what circuit is containing IS in some way, shape, or form. And we do have to maintain separation, or we can maintain separation by using, again, shielded cables, armored cables, and that. The important thing to note here is that what I'm telling you, that's what the standards say. Just because the standard says that, that doesn't necessarily mean that every company or client will actually say, hey, we accept that. Because the standards are bare minimums, right? So some companies will say, hey, that's great. The standard says that, but this is the way I want you to do it. I want you to use blue cable. I want you to maintain this separation. But sometimes, the company's customers don't tell you that. and you have to make that determination if you're a skid package builder. So this is where, you might have to have a discussion with the customer. A little bit about sill levels and mitigate hazardous area classification. So we won't really go through this. We could spend hours talking about this. But what I will recommend, GMI has a fantastic book on safety instrumented systems, and it's based upon the 61511 standard. And it basically talks about functional safety and how reliable our systems are. So that's really where this comes into play. So functional safety is an important part of our overall system design, especially when we're talking about fire and gas systems or critical circuits in which we just have to make sure that these products are going to work when needed. So they kind of dovetail along with the EX standards, but it is a separate knowledge base. And again, that book is fantastic, and even better, it is free. So you can request it from Barbara, or I think we can actually go online, and I think all you have to do is register and you can download it.
Correct. Yeah, you can get your ebook from our website.
Yeah. There you go. So this was one question, and it's asked a lot. Technically, there isn't one right protection method. Some of them we just can't use, right? Like for intrinsic safety, we only can use that for basically low power circuits generally, right? So IS makes sense for low power monitoring circuits. We're not going to be able to make things intrinsically safe like a motor starter or light fittings. Those consume too much power, so intrinsic safety doesn't make sense. If I have VFDs, I've got high heat type products. I might require something like a pressurized enclosure and maybe a vortex cooler to try to do something with the heat. If I have a lot of electrical switching devices that are somewhat high power, maybe flameproof is the best method. So there is no necessarily one perfect method for all applications. And I think that's one of the beauty of the EX system, if you will. You have options. And if you know what your options are, sometimes you can find solutions that are very creative, maybe combining some of these protection techniques with a single product, or utilize them in such a way to where it truly is a safe, even a safer than what it might normally be. So it takes some knowledge when I'm designing something, understand the pros and cons of all the protection concepts and where we can and cannot use them. That's an important thing. And that's one thing that we do talk about a lot within our training courses, the pros and cons of all of these protection concepts. We talked about NEMA ratings and IP ratings, so we've already mentioned that. ATEX, IECEX, and SIL. So again, ATEX and IECEX deal with equipment used in hazardous locations. So ATEX, and I think we did have a question of whether or not ATEX still applies, and it's still there. It refers to the European Union directives and standards for equipment used in explosive atmospheres. And the prefix standard is the EN version of the 60079. The IECEX is a certification scheme developed by the IEC, and it does use the zone classifications, and it follows the 60079, the IEC versions. And the whole intent of the IECEX was to have a globally harmonized approach. So that's the approach of the IECEX. ATEX is really meant more for free trade and reduced trade barriers within the European Union. So that's kind of the aim of both of those organizations or documentation or schemes. And they're very similar. Protection concepts are the same. SIL is not related to hazardous area classification. And again, it deals with functional safety. For wiring methods, people always ask, which wiring method should I use? Because we've talked about protection concepts, but now what do we do? So within both the US and Canada, we've adopted the zone concept, but we still follow the installation and design details for the interconnection that are referenced either in the National Electric Code or the Canadian Electric Code. And they will have different requirements for things like cables, cable glands, cable connectors that are different than what we would find in the 60079-14. And that standard is the standard that if you are doing any design work around EX, that's the most important standard, I think. And most of these competency programs, when we teach these programs, a lot of that is based upon the 14 standard. So you will find a lot of similarities between what's done in Canada, in the US, and Australia, and Europe, Middle East, various parts of the world. There is a similar concept, but they're not exact. So we always have to understand exactly what the wiring regulations are we using in this particular market. What else needs to be considered when designing EX systems other than product? Obviously, regulatory requirements and client wiring requirements, third-party specific requirements. We run into applications maybe in the marine or offshore business where there may be some ABS or DNV regulations. This is the other thing, the country or project specific non-hazardous wiring regulations. So there's a whole set of IEC standards, the 60364 set of standards that deal with general wiring. In the UK, we follow BS 7671. In Australia, we follow the AS 3000. In the US, we follow the National Electric Code, so forth and so on. So once we've clarified that, the basis of design will most likely follow for hazardous location, the key points from that 60079-14, which has been adopted around the country as country-specific standards. So it could be an AS NZS for Australia and New Zealand, EN for Europe, NBR for Brazil, and so forth and so on. This was a very interesting question. I know we're kind of running almost near the end here, but and I hope this person is online because this was a very, very interesting question, at least for me being a nerd in this business. So the 60079-33 is a very unique standard, and it's a standard that deals with what is called special protection. And it's indicated by EXS. And the question was, how can a IEC EX product certified under that be marked under the ATEX scheme? And the reason why I think this question was asked was up until recently, there was not an EN version of that 60079-33. It was only published as an IEC standard. And then it was updated here recently and published in 2024, and it was adopted as an EN standard. So there's an example of a special protection. In this case, this is actually a pneumatic powered light fitting that in this case is ATEX, and it is certified to the EN standards, but it's also references the old IEC version of this, and the certification body used that as the basis for their certification. So there's your marking string under ATEX, and there's your protection concept. In this case, it's EXSB 2C T4GB, meaning that this product is suitable for a zone 1 area, all gas groups, and so forth and so on. So how can we download the wall chart? And Barbara, I think this is what you do,
Yes.
right?
Exactly. So here I just put a few screenshots. You can go to our website, so gminternational.com, go under contact, downloads, no, support downloads. You click there, and then Bob, you click one more time, you will get
Yep.
these links for the PDFs. So you can
There
have
you
the
go.
seal poster that Bob showed, the hazardous area poster, as well as our product overviews, the seal manual preview. So you can have that information available on the website.
Fantastic. And I apologize for having my coughing fit. I've seemed to have recovered somewhat, but I know we have some additional questions that hopefully we have answered, but I don't know if we've answered all of them.
There was one, I can read a few ones. So they say for standard shelf items, when receiving an offer from the supplier, we typically receive product catalogs that reference certifications marks indicating the equipment is certified. However, the specific certification details shown on the manufacturer's nameplate are not known until the product is actually manufactured. How should this be interpreted or handled during a bid procurement process?
Yeah, so on standard shelf items, receiving the offer, we typically see product catalogs that reference certification marking and equipment. Yeah, so in that case, and I've seen this where maybe, a manufacturer will reference all of these particular certs. what in that scenario, I would absolutely reach out to the manufacturer and ask them specifically, please send me the information of how this product shall be marked. So we want to make sure that you've got that product. And again, some manufacturers are pretty good about that, but other manufacturers, they may be reluctant. If any manufacturer is reluctant to do that, then find another, I suggest find a different manufacturer. Yeah.
Mhm.
And then I know
There,
go ahead.
there are some non-electrical items subject to the EX certificate. Which
Yeah.
standard covers that?
Yeah, so those are the 80079 standards, and there's two of them. There's an 80079-36 and an 80079-37. The 36 basically covers uh, the concepts under mechanical equipment for use in hazardous locations. And then 37 comes up with the various protection concepts that you can use to employ for mechanical equipment for use in hazardous locations. So that they've been published. It's actually now a joint ISO EN IEC 80079-36 and 37. So those are the standards you'd want to look into for mechanical equipment.
Mhm. And I think one more, is it necessary to use heat shrink tubing with glue in an EXD enclosure?
Uh, that I don't know. I'm trying to think of an application. So if I have spares, right? For example, what is common is I have maybe 10 terminals and I've got 2 spares, 5 spares, whatever. What is acceptable if I have to land, the ideal situation, if I have spare conductors, I want to have spare terminals to be able to land those in. But I cannot just clip them and let them hanging. What I would do at that point, I would take a piece of heat shrink, fold it over, take a cable tie, and then that's indicated as a spare and leave it floating. I don't know if that's your question or not. Heat shrink with regards to, you can use it certainly on the inside of EXE enclosures. Um, you know, but there's no mandated requirement that you must use heat shrink unless there's some specific applications I'm just not thinking of right now. I know there's some other stuff, they meant NEGB. So there was a question, I meant, is any JB certified as EXI and maybe blue colored, or only any box including IS circuit should be considered as an ISGB? So what we're basically saying, there is a requirement within the standard, and again, it's in the 14 standard. If I have a single circuit intrinsically safe box, junction box, the standard actually says that that junction box does not require certification, but it would require a label on that box to say contains intrinsically safe circuits. On the other hand, and when I say a general purpose box, I mean just an IP rated box, a NEMA box, a non-EX box. On the other hand, if I have 2 circuits going into a junction box that's containing IS, then the box itself must meet the requirements of 60079-0, which in effect tells you it must be a certified box. So in that case, I would use an EXE junction box because that meets the requirement of -0. And then I'd put a blue label on it to say this contains intrinsically safe circuits, and put blue terminals and so forth and so on. Hopefully that answers your question there. Barbara, did we, you still with me, Barbara?
Yes, I am
Okay.
here. Yeah, I think we're running a little bit out of time.
Yeah,
I think we can answer the rest of the questions via email. We'll get all this information, and I just want to thank you, Bob, for co-hosting this event with me. It was very interesting information, and great reminder of some of how to go over the wall poster for this
yeah,
for the 3 hazardous areas, 3 standards that we have to deal in internationally speaking, right?
right, right. Well, and again, I apologize for my coughing and choking fit here, but I seem to have survived. But I'm going to have to probably drink a lot of water here. But I really want to thank you, Barbara, for doing this. And I want to thank you all very much for attending. And please reach out to Barbara or myself if we can be of any assistance, or if we didn't answer your questions during the webinar, please feel free to reach out to myself, reach out to Barbara. Um, I think that GM International email that is on there, that'll go to GM International. They'll forward it to mine. But if you want to reach out to me directly, it's just bob.johnson@sourceiex.com. You can just drop me an email at that point and I'll get it right away. I'll get it either way. Doesn't matter.
Okay.
So again, thank you so much for everybody for attending. I know we ran a little bit long, but hopefully you were able to gather the information that you wanted to know.
And we'll see you all next month. We're doing another one. So hopefully we'll see you guys there.
Sounds great. Thank you so much. Bye-bye, everybody.
Bye.